Okay, so what we're going to look at today is confidence intervals. Confidence intervals are just simply the range or the sample size hovered around the mean. So, a confidence interval for the mean is an interval estimate around a sample mean that provides us with a range of where the true population lies. So, when we're looking at the confidence interval, we're looking at what that range is, and typically you calculate the upper and the lower limit along with the margin of error, and it's based on a critical value. So the first step to doing a problem like this is we're going to look at what our critical value is. In this case, we have a confidence interval of 90%. And so this is going to be looking at a two-tailed test. So if our mean is in the middle, we have an upper and a lower limit. And so here you would have, you're looking at what that range is hovered around the mean. And the critical value is going to be based on this critical z-score. And so for a 90% confidence interval, our critical value would be 1.645 is what we would base that on. So our critical value in this case, based on 90% confidence level, would be 1.645. The next step is we're going to determine what our standard error for the mean is. And what that looks like, your formula for that would be this. You've got, and this is when the standard deviation is known. And so you have your standard deviation over the square root of your sample size. So we're looking at a random sample of 35 used car lots that found the average price of a used car was $11,750. Assume the population standard deviation is 1,225. So we're going to take 1,225 over the square root of 35. And that is going to tell us what the margin of error is. So if I tend to find the square root first, and the square root of 35 is going to be 5.92. So, and then I divide. So we got 1,225 divided by 5.92 for a standard error of 206.93. So this is my standard error, and my mean is 206.93. And so what I'm going to do with that standard error is I'm going to calculate my upper and my lower limit. And so my upper and my lower limit are going to be used by using the formula here, and this will also tell me my margin of error. I'm going to take my mean plus my Z critical score over let's see. And I'm going to take the 129, my mean, which was 11,750, plus my critical value, times my standard error of the mean. When I calculate that, I get and if I add these together, I get a total of 12,090.39 as my upper limit. And then my lower limit is going to be calculated by subtracting the same value. So I would take 11,750 minus the 340.39. And my lower limit would be 11,409. And so what you have here, and I'm out of room, but what you have here is you have, and I'm going to put it up here, 12,090.39 as your upper limit. And then, and I did this backwards. You would have your lower limit first because that's negative. You got your lower limit with the mean in the middle. Your mean score was 11,750. Which is in the middle. And then your upper limit would be 12,090. Now what this means is if you had it here and you were to draw it, your mean's in the middle, 11,750 would be here. Your upper limit would be here, your lower limit here. So that is the range hovered around the mean. So how you would calculate your margin of error is you would take 12,090 minus 12,090.39 actually, minus your mean of 11,750, and your margin of error is going to be 340.39, and that would be your margin of error. For number 3. Your confidence level is going to be down here, 90%. Now, I did not have on here your upper and lower limit, but on the test, you would have the lower limit and the upper limit. And then the margin of error is what separates it right here. So let's work another one. So here, I'm going to do a different color. Let's see. I'll do this in red. Okay, a random sample of 30 restaurant servers found that the average tips per shift was $150. Assume the sample standard deviation is 25. Using a 95% confidence level, calculate the confidence interval. So down here, you're going to look at what your, based on 95% it would be 1.96. So 1.96 is going to be my critical value there. The confidence interval is going to be 95%. Okay. Now, what does that mean? Well, based on this situation, 95% are going to fall within this range right here, okay, around the mean. 95% here. Previously, it was 90% in the earlier problem. Now it's going to be 95% hovered around the mean. Now, the standard error of the mean is going to be calculated again by using this formula right here, where you have the standard deviation over the square root of n. So in this case, our standard deviation was 25, and we had 30 restaurant servers. So I'm going to say 25 over the square root of 30 to calculate my standard error. So my standard error is going to be, if I find the square root of 30, we've got 25 over 5.48, okay? And then if I divide that, you should get 4.56 as your standard error. Okay, now your margin of error we're going to come back to. But I'm going to calculate my upper and my lower limit by saying the mean minus my critical z-score divided times so I'm going to take my mean, which is 150 minus my critical value of 1.96 times my standard error. And so if I take 1.96 times 4.56, that's going to give me my margin of error of 8.94, okay? So I'm going to take 150 plus or minus 8.94, and that's going to give me, I'll do the minus first, 150, the lower limit, minus 8.94, and that gives me 1.41. So if I'm looking at my mean's in the middle, okay? My mean was 150. So 150 is going to be in the middle. And then my lower limit was, hang on, I did that wrong. 150 minus 141.06. So my lower limit's going to be 141.06. And my upper limit $150 plus 8.94 gives me 158.94. So what does this mean? Well, This means that 95% of restaurant servers found the average tips per shift were 150. Assume standard deviation is $25. So 95% of the tips are going to hover between $158.94 and $141.06. So 95% are going to fall within this range. Now, I'm going to look too at my margin of error is going to be 8.94 margin of error. And so if I was looking at it here, they're going to fall right here, 95% around the mean in the average tips per shift.